So we talked about this equation right here, y equals mx plus b. And what is the b? Good. Y-intercept, and what is the m? Good. And if you have, let's say you have, let me go like this. If you have the equation y equals 30,000, let me think here. So it's going to go, yeah, x plus 10,000. Let's say this is your income starting from the time you are 18 years old. Income per year. So you start when you're 18. Okay, so maybe you have a part-time job or something like that. So your starting will be year 0, okay? And then your first year, so when you're 19, year 1, 20, year 2, and so on, like that. So I'll go over here. I can go like this. I can go like this. And if I say x is 0, do you know what y is going to be? Nope. You're going to want to look right here. Look right here. If x is 0, then you're going to plug 0 in right here for x. So you're going to write this down. You're going to go, all right, well, y equals 30,000. And what operation is happening between this 30,000 and the x? What's happening between the two? Yep, because there's no plus sign. If there's no sign, it's multiplication. Same thing as like parentheses. So they're multiplied together. So I'm going to plug in a 0 for x. So instead of x, I will be multiplying a 0 plus 10,000. Well, what is 30,000 times 0? Right. So you're going to end up with 0 plus 10,000. So how much are you making in year 0? $10,000, right? So this is on year 0, you're 10,000. All right, so then this is 20,000, 30,000, 40,000. Okay. All right, yeah, so year 0, you're at 10,000, which makes sense because that's your y-intercept. So I could have asked you, well, how much did you make from the very beginning? And your answer should have been 10,000 because the very beginning means that x is 0, which means the very beginning means what is y when x is 0? And that's exactly what the y-intercept is. So when x is 0 is right here. Y is 10,000. So we have 10,000. How much do you make after the first year? Well, we're going to go. So that's right here is year 0. Exactly. So what did you plug in? Good. So our x will now be 1. 10,000. I don't know why there's an equal sign there. Plus. And you're going to have 40,000. That goes here. How about 5? Like after the 5th year. How do we figure that out? Wait, I forgot to plot the other point. So I have to go 1 and then right here for 40,000. Plot the other point. I'm sorry. So what do I plug in for year 5? Just tell me what to write down. What do I write down? I'm more interested in the equation than the answer. So it'll be 30,000. Tell me your setup. What did you do? 30,000. What did you use for times? No, what symbol did you use for times? Did you use the X? Did you do this? 30,000 times 5 or 30,000 times 5 or 30,000 times 5. This one here? Perfect. Good. Yes, that's good. And then what did you get for that answer? Okay, then what? Perfect. So you got 150,000 and plus the 10, 160,000. Okay, so now if I actually told you that this equation were true, like I have a crystal ball right here, and this is the magic equation for you. Do you think this equation would be kind of useful piece of information? If I said this applies to nobody else, everybody has their own equation, you have yours, this is yours. Would you be very interested in sitting down with a calculator with this equation? Why? It's simple, but if somebody gave me this and I'm 16 years old, I'd be like, hold on a second. So you're telling me that if I stay on this path, this is how much money I'm going to make every year? And it's going to go up by this much every year? What's that? Because this equation will tell you how much you're going to make in 20 years. I don't even have 20 years here. I can tell you how much you're going to make if, let's say, you lived forever, how much you can make in 1,000 years. I can tell you how much you're going to make in 40 years. In 45.3 years. You see, what I'm saying is that these equations that are like, and it's kind of a silly example because there's no equation for how much money you're going to make, but these equations allow you to make predictions. You could predict things. You could find values that didn't exist, like that you don't know. Like you're like, well, if things increase like this, then okay, what's that number going to be in 10 years? What's that number going to be in 15 years? You cannot, but I know what you're talking about. But you can, but there's other equations. There's equations that can map the path of a rocket like this. You can say like, all right, if it follows this path, and where exactly will it land? Like after whatever, 30 minutes. Or how high will it be? Or even like a diver, someone diving off a diving board. How high will the diver be? 0.5 seconds after he jumps off the diving board if he follows this path. The equations, the reason why they're used is they allow you to kind of predict where things are going to be. And there's different equations. The one that we're learning now is a linear equation. And what's unique about a linear equation is the same rise over run. So in this case, that rise is 30,000. You see, it's going to be 30,000 because I can write this 30,000 as a fraction, and it's 30,000 over 1. So up 30,000. So if I went up 30,000 from 10,000, where am I going to be? If I go up 30,000 from 10,000, where am I going to be? Yep. So let's say I start at 10,000, and then I want to go 30,000 higher. So like right here, look at this axis right here. You see how it's at 10,000? Now let's say I go up 30. That's 10,000, that's 20,000, that's 30,000. What's this number here? Yeah, 40,000. So if I go up 30,000 from 10, that's the same thing as saying, well, you could just go like 10,000 plus 30,000. And that's 40,000. If you go, I was saying if you go up 10,000, I'm sorry, if you go up so from 10,000, if you go an additional 30 higher, correct. And how many years did it take to achieve that? To go from there, to go from there to there, to make $40,000. How many years did it take to do that? Look right here. This is 1 year right here, and I go straight up. What's this number? What's this Y value? See? So this is 1 comma 40,000. So after 1 year, I went up. After 1 year, I ended up at 40,000. So with 1 year, you're gonna make $30,000 more than the year before. You see? So if on the second year, we didn't put a dot there, but I'll tell you where it's going to be. It's going to be at 70. It's going to be right here. So at the second year, it's going to be right here. And look, this is 40,000. So what's this rise? Well, not really 3, but I know why you're saying that. You're saying it because of 1, 2, 3. But look at these numbers. The rise is 30,000. You do. It's just when you do it on the problems that you've seen, you don't count up because they're all by 1. But if they were all by this other number, then you have to look at the other number. You see, so how much is it? So you all you have to do is you just have to, if you go like this, and you say, all right, well, this is 10,000, and I'll just give a different example. And this is 15,000, and this is 20,000. How much is 1 now? Well, it's going from 10 to 15. It's going from 10 to 15. Watch this. Let's try this. Let's say this is not 10,000 anymore. Let's say this is just the number 10. And let's say this is the number 15. How much do you have to go up to get there? So you go this is basically, if I did in terms of money, let's say you made $10 today, and then tomorrow you made $15. How much more did you make? 5. Same thing, 5. So one of these is 5. This right here is 5,000. See that? That's 5,000. How much is this? This is now going from 40,000. If we go from 40,000 all the way to 70,000. How much did that go up? 30,000, right? So see this number right here? Where it's right here. There's that 30,000. There's that 30,000. It's that number is your rise. And the run is 1. The reason why the run is 1 is because when you see the number 5 or 30 or whatever, and you want to write it as a fraction, you just write it over 1. You see, so it's 30,000 over 1. And your 1 is this 1 year, right? That's your 1. So we keep doing that. If I do it again, it's from 70,000 and I go up my rise, where am I going to end up? From 70,000. I'm going to go up my rise. Here's my rise. Or my rise of a run, but my rise. This number right here. From 70,000, where do I end up? How did you do it? How did you add that up? And how did you do that? Did you write it down or did you do it in your head? How did you do it? Did you do it like this? 30,000. What'd you do? Oh, plus you did 70,000. You did that? So what is this number right here? What is the point of this number? This number. Yeah, your slope, right? And so this is how much, in terms of this problem, it's how much you're going to increase every year. It's always consistently going to be the same thing every year. It's always going to be 30,000. And then over time, it amounts to a lot. Pretty quickly, actually. Yeah. And then if you connect all your dots, what do you get? What do you get if you connect all your dots? A straight line. So linear equation. It's going to be a line. I'm going to stop the recording.